Welcome, folks. Today we're discussing semantic fidelity and similarity scores, two really important concepts in natural language processing and AI evaluation.
Sounds interesting. Can you start by explaining what semantic similarity actually means?
Sure. Semantic similarity is all about how much two pieces of text share the same meaning, even if they use different words or have different structures. For example, the experiment was successful, and the test produced positive results mean pretty much the same thing, even though they're worded differently.
I see, so it's about the underlying meaning, not just the words themselves. And how do we measure this similarity?
That's where the similarity score comes in. It's a number, usually between 0 and 1, that tells us how similar the meanings are. 0 means no similarity at all, and 1 means they're identical. Modern methods use vector representations of the text, like BERT embeddings, and then calculate the distance between these vectors, often using cosine similarity.
Okay, got it. So we're turning text into vectors and then measuring how close those vectors are. What about semantic fidelity? How is that different?
Semantic fidelity is about how accurately a generated or transformed text keeps the meaning of the original. It's not just about being similar, it's about being faithful to the original information. Did it retain the essential information without distortion, omission, or hallucination?
So fidelity is more about accuracy and faithfulness, while similarity is about general closeness and meaning?
Exactly. Two sentences can be similar in topic, but still have factual errors. Fidelity emphasizes semantic faithfulness rather than just surface resemblance. For instance, if an AI summarizes a research abstract, semantic fidelity checks if all the key claims and results are still accurate.
That makes sense. So how do we actually compute semantic fidelity in practice?
Well, the process is similar to calculating semantic similarity. First, both texts are encoded into semantic vectors. Then, a similarity function, like cosine similarity, calculates the distance between the vectors. But importantly, fidelity often includes extra steps like alignment or entailment checks to see if one sentence logically follows from the other. Some systems even use natural language inference models to check for contradictions.
Interesting. So it's not just about the vectors being close, but also about logical consistency. What are some real-world applications of these similarity and fidelity scores?
Oh, there are tons. In academic plagiarism detection, similarity scores can identify paraphrased copying. Search engines use them to rank results by meaning, not just keywords. Conversational AI uses them to evaluate response relevance. And in summarization and translation, fidelity metrics ensure the correctness of information.
I see. They're used in quite a few different areas. Are there any limitations to keep in mind when using these metrics?
Definitely. Similarity models can sometimes overestimate closeness if texts share context but differ in factual details. And fidelity evaluation can be tricky when there are multiple valid interpretations. Things like domain-specific language, sarcasm, or implicit meaning can also throw things off.
So, it's not a perfect system, and we need to be aware of potential pitfalls.
Exactly. That's why robust evaluation frameworks usually combine multiple metrics, including lexical, semantic, and logical measures, to get a more complete picture.
Got it. So, to wrap things up, semantic similarity tells us how close two texts are in meaning, and semantic fidelity tells us how accurately meaning is preserved from a source. They're both valuable tools, but they have their limitations.
Precisely. They're complementary tools that, when used together, provide a powerful framework for assessing the quality and reliability of language generation and transformation systems. Well, that about wraps it up for today's discussion on semantic fidelity and similarity scores. Thanks for listening, folks.